Welcome back, everyone, to another AI Talks Deep Dive. I'm so excited for today. We're going to get into perceptrons.
Yeah, these are really cool.
They're like the granddaddies of neural networks, kind of like where it all began. And we're gonna use this paper called Perceptron in Machine Learning as like our guide through this whole thing.
Perfect.
So perceptrons, they do this really basic thing called binary classification. Deciding if something belongs to one group or the other. Like, is this email spam or not?
Right. A very simple yes, no.
Yeah.
Is this a cat or a dog?
Yeah, exactly. So it's like a digital sorting hat, right?
Exactly.
Just figuring things out. So maybe you can kind of break down, like, what makes a perceptron unique? Like, what's the special sauce here?
So Perceptron is like a really, really basic network. Imagine just like one layer of input. Think of them like sensors, gathering information from the world. And each of those inputs is connected to an output. And those connections, they use what are called threshold logic units. And those are the things that allow it to make those yes or no decisions.
Okay, so it's like taking in information and then making a choice based on that.
Exactly. And it's particularly good at what we call linearly separable patterns. So if you imagine like a graph, you can draw a straight line to separate the data. That's what it's really good at. So like think of, I don't know, sorting apples from oranges just based on color. Red on one side of the line, orange on the other.
So it's like a really basic sorting machine. So then if it's a machine, let's break it down into its parts.
Yeah.
What are the pieces, the building blocks of this thing?
Okay, so we can start with input features. You can think of those, again, like the senses. They're taking in information. Each of those inputs has a weight. So that determines how important that input is.
So like some inputs are more important than others?
Yeah, exactly. It's like, adjusting the volume knobs on different instruments in a band, right? Some are louder, some are quieter. And then we have what's called the summation function. And that just adds up all those weighted inputs.
Like tallying the votes.
Exactly, yeah. And then that sum, it goes through something called the activation function. And that is like the decision maker.
Okay.
It uses a threshold, so like a pass-fail mark, to decide whether the output's going to be a 0 or a 1.
Oh, so it's like evaluating the evidence and then making a judgment call.
Yeah, you got it. And then that judgment call results in the output, the final decision, yes or no. We also have something called the bias, which adds a little bit of flexibility to the decision-making process, kind of like, giving one side a head start in a race. It just allows for a little more nuance.
Gotcha.
And then finally, the most important part is probably the learning algorithm. And this is how the perceptron actually learns from its mistakes. It can adjust those weights and biases over time to get better at its task.
Gotcha. So it gets smarter.
Exactly. That's what we want.
Okay, that's cool. So you mentioned different types of perceptrons. What are the flavors?
We've got single layer perceptrons. Those are the ones we've been talking about. Good for those simple tasks, like the apple and orange example, where the patterns are linearly separable.
Okay.
But they really struggle with those more complex relationships, and that's where we get into multi-layer perceptron. And these guys, they have multiple layers, so it's like, multiple layers of those nodes all connected together.
Right.
And that allows them to kind of capture those more intricate patterns. So things like, I don't know, facial recognition or natural language processing, those use these more complex ones.
Yeah, like things that are way more complicated than just color.
Exactly. Way more complicated.
It's like leveling up from a basic calculator to a supercomputer.
Exactly, yeah.
So why is it important to understand these early perceptrons today?
So they might seem really simple, but they really laid the groundwork for all of the more advanced neural networks that we have today. All of those concepts that we talked about, inputs, weights, activation functions, those are all still used in these huge complex systems.
So it's like understanding the history of computers.
Yeah.
Starting with those room-sized ones to get to our smartphones.
Exactly.
Okay. So I guess to wrap up, we've learned about the structure of a perceptron, the different parts, and how those ideas kind of pave the way for modern AI.
Exactly. It's the foundation. And it makes you think, if we understand these basic building blocks, can we predict where AI is going next?
Right.
And what kind of ethical considerations do we have to think about as these systems get more and more complex?
Right. That's a great point. It's definitely something to think about as we keep going deeper into the AI world.
For sure.
All right. Well, thanks for joining me for this deep dive on perceptrons.
Of course. It was fun.
It was really, really cool.